All right, quick video on systems of linear inequalities. I'm just going to go through a few of the examples on the slides here. So just a quick reminder, when we graph linear inequalities, it's very similar to graphing a line. The equations will look just like y equals mx plus b, but then instead it might be like y is less than 3x plus 6. So instead of the equal sign, we have the inequality symbol there. So we want to graph it just like we graph a line with the slope and the y-intercept. Remember that the y-intercept does need to be along the y-axis. And then when we graph linear inequalities, we need to know if we're going to graph a solid line or a dashed line. So remember, you make a solid line when it's less than or equal to or greater than or equal to, because this boundary line, the points are included on that boundary line. And we make a dashed line when we have just less than or just greater than, because the points along that line are not included. Then we shade one side of the line. Remember, you can always check a test point to decide which side you shade. And then just another reminder to have y by itself before you start graphing. So we'll solve for y if needed. All right, so these two linear inequalities is a system together. So we're going to graph each one and do the shading. And then when we have a system of inequalities, our solution will be where the shading overlaps. Similar to when we graph a system of linear equations, we graph the two lines and the point of intersection is the solution. So this is the point of intersection for the shading. So both of these lines are already in slope-intercept form. So if I look at the first one here, has a slope of 2, or that's 2 over 1, and a y-intercept of positive 3. So I'm going to start at positive 3, and then from positive 3, it's slope of 2, so up 2 over 1. Up 2 over 1, or down 2 and left 1, down 2, left 1. And then we're going to have a solid line, and because it's less than or equal to, we should be shading below, but we'll test a point just to make sure that that's correct. So I'll get my line tool here, solid line. And then let's just test the origin since it's not included in the line. So I'm going to plug in 0 for y and 0 for x, and 0 less than or equal to 3 is true, so 0 is a solution. So I will be shading below that line. I'm just going to draw arrows to remind myself that I'm going to be shading below that line. I'm not going to do all the shading quite yet. All right, the second line then. Y greater than or equal to x minus 1. This is in slope-intercept form already as well. I have an x here, so that means I have a 1x. So slope is 1 or 1 over 1, and y-intercept at negative 1. So I'm going to start down here at negative 1, and then positive slope, so up 1 over 1, down 1, left 1. So up and right or down and left for positive slope. I'm going to make sure that we're going uphill from left to right. This one also has a solid line when we are graphing it because it's greater than or equal to. The greater than or equal to does also tell me that since y is greater than or equal to that line, we should be shading above. Again, we'll test a point just to make sure. So I'm going to make that line orange. It's a solid line. Whoops. Okay, and we should be shading above, but it looks like the origin is open still right here, so I'm going to plug in 0, 0 again. 0, 0 greater than or equal to 0 minus 1, so is 0 greater than or equal to negative 1. That is true, so we are shading above. If I go back up here, you'll see that we're shading below the blue line, but we're shading above, let's see what color, put that one in orange, above the orange line. And hopefully you'll see that below the blue and above the orange, they're going to intersect right here. So similar with a system of linear equations, our intersection point is our solution. For a system of linear inequalities, our solution set is the intersection of the shading. And then all the points along the two boundary lines as well, because it was equal to those. So get rid of this shading. So the solution here is in green, and all along this boundary line, along these boundary lines as well. And then everything in between. So we have quite a large solution set there. So we do the shading for each line, and our answer is where they intersect, where the shading intersects. So we'll do another example here. Notice that these two equations in this system are not in slope-intercept form. So the first thing you'll need to do is solve each of those equations for y. So the first one I'm going to have to divide by -2. Remember, when you divide an inequality by a negative number, you do have to flip the inequality sign. So instead of less than, it becomes greater than. 4 divided by -2 is -2x. So this has a slope of -2, or -2/1, and the y-intercept, since there's nothing following behind the x, the y-intercept is going to be at 0. So we have a y-intercept of 0, so that's right at the origin, and a negative slope this time, so make sure you're going downhill. So down 2 to the right one, down 2 to the right one, or up 2 to the left one, up 2 to the left one. So in the end, you want to make sure that your line is going downhill. This is just greater than, so our line is going to be dashed. And y is greater than that line, so we should be shading above. So let's get our dashed line here. Make it blue to match my points. Nice blue dashed line. And I'm guessing we're going to be shading above. So up here, 0, 0 is taken on this line, so I can't plug that in. I'm going to have to choose a different point. I'm going to stick with 0 for x, but let's try, we'll do 0, 5. So 0, 5. I'm plugging in 0 for x and 5 for y. So 5 greater than -2 times 0. Is 5 greater than 0? Yes. So I am shading towards that point. Remember, if I would have answered no to that question, it would have been in the reverse. I would have shaded below instead. But it's true, so this is a point in my solution set. So I'm going to shade towards that point. All right, now I need to solve for y on the other equation. I'm going to have to move this down a little bit here. So we got 2x plus, this pen does not work very well, 3y less than or equal to 6. So I'm going to start by isolating the y variable and subtracting 2x. So we're going to get 3y less than or equal to -2x plus 6. Get the y by itself, divide by 3. I did not need to flip my inequality this time because I'm only subtracted the 2 and then I divided by a +3. So no need to flip the inequality. So y is less than or equal to -2/3 will just stay -2/3 x, and 6 divided by 3 is +2. So this one has a slope of -2/3 and a y-intercept at +2. So a y-intercept at +2, we want to go downhill again, so down 2 to the right 3, down 2 to the right 3, down 2 to the right 3, or up 2 to the left 3, up 2 to the left 3. This is a less than or equal to, so we're going to have a solid line this time. And this says that we're going to be shading for less than, we should be shading below the line. We can test a point. This time the 0 is open for that line, so we could test 0, 0. Go right back to the original here, plug in 0 for x, you're going to get 0. Plug in 0 for y, you're going to get 0. 0 plus 0 is less than or equal to 6. 0 is less than 6, yes. So we'll be shading below. Now you can see that they're going to overlap above the blue dashed line, and under the pink line they're going to overlap right here. So the solution set will be right here. Now if I was shading, sometimes they don't always overlap in the middle here. Sometimes they overlap up here. So if I shaded above both these lines, then this square here would have been the solution set if it was above both lines. Or if it would have been below both lines, then we would have shaded down here. So the solution is wherever the shading overlaps. Notice that the points along the dashed line are not included in our solution this time, but the solid boundary line, those points are included. We'll do one more example because this system has 3 lines, but notice that 2 of them are part of our special cases. So the first thing I'll do with this top one is solve it for y. It's y plus 3 greater than or equal to 0, so I'm going to subtract 3, and y is greater than or equal to negative 3. So there is no x here, so essentially our slope is 0. We have 0 x's, and your y-intercept is negative 3. So you find the y-axis, so x, y is equal to negative 3 right here. There's no other values here, slope of 0, so it's just a straight horizontal line. And it's a solid horizontal line because it's greater than or equal to at negative 3. Now y is greater than negative 3, that should be above, because the y values are bigger than negative 3, above that line. Like if you plugged in 0, 0 is greater than negative 3. So we shade above. So we're going to shade above that line. The next one, x is less than negative 1. It's another one of our special cases. So we find negative x equals negative 1 right here, and x equals negative 1 everywhere. So there is no y. This is a special case. This is one of those x equals, and it's a dashed line. It's going to be a vertical line at x equals negative 1. Then to decide where we shade, x is less than negative 1, so we're going to be shading to the left of that. So far we got this square right here is where they're going to overlap, over here to the left, above the pink and to the left of the purple dashed. So now we have one more line, and we will need to solve that one for y. I'm going to write that down here, 2y less than or equal to 4x plus 8. So I'll have to first divide everything in here by 2. This pen will work here. So we get y less than or equal to 2x plus 4. So I'm going to start at positive 4 and a slope of 2 or 2 over 1. So it's positive slope, so up and to the right, up and to the right, or down and to the left, down and to the left, down and to the left, down and to the left. Okay, so it is less than or equal to, so it should be solid, and we should be shading below since it's y is less than that line. So I need a solid line. Oops, I'm going to have to go back a little bit here. Just going to have to extend that line. There we go. And we should be shading below, but let's just double check that. We'll plug in 0, 0. 0 less than or equal to 2 times 0 plus 4. That would be 0 less than or equal to 4. That is correct. 0, 0 is a solution. So we're going to be shading below that line there. So we got to be a little careful here, but it's above the pink, to the left of the purple, and below the blue. So we're just right in this triangle right here. So it's a very limited set of points that are our solution. We don't want to go over that boundary line there, but just these points within that small triangle are part of our solution set for this example. All right, look on the online notes. There is a couple more examples. I only went A, B, and C. There's D and E as well. So if you'd like to look at those notes as well. But just a few reminders. Remember to get y by itself, and you want it to be, the inequality mx plus b so you can graph it. Remember to check for solid or dashed line. Shade one side of the line at a time. And then the solution is where two or more of the shaded areas meet. So if you shade above this line and above this line, then the shading is going to overlap here, and that's going to be your solution. All right. Thanks for watching.